Good afternoon all of you. So today we will start our unit number 4. The unit number 4 name is the electronic instrument. Our subject is basic electronics. In that our first topic is the multimeter. Basically in an electronic instrument we have to study different instrument that we are using either for our we can say college purpose, either industry purpose, then medical application and all that. So first one is the we can say that the first one is the multimeter. So all of you know, as the name indicates, multimeter that are used to measure more than one quantities. Generally that multimeter used for to measure either AC or DC current, either AC or DC voltage, either we can say as a resistance. There are different two types of a multimeter. One is the analog multimeter, one is the digital multimeter. So basically we can say this is a versatile instrument. It having voltmeter that measures a voltage, it having a ohm meter that measures a resistance, it having a ammeter that measures a current through a component. So by the definition we can say that means suppose we have to define a basic digital multimeter, we can define it as digital multimeter is an instrument that are used to measure a DC voltage, AC voltage, DC current, AC current, resistance, conductance and decibels and display the whatever the quantities on a digital display. Some DMM also have means digital multimeter also having a capability to measure a temperature or a frequency also. The DMM also replaced by completely analog multimeter due to of many reasons. As you know, as there are two types of a multimeter, one is the analog multimeter, one is the digital multimeter. Basically analog multimeter having some disadvantages, so we go for a digital multimeter. Digital multimeter having a more accuracy as compared to analog multimeter, and in analog multimeter the scale is not we can say as a linear, as in a digital you can see the value, exact value on that particular multimeter. So basically we go for digital multimeter. So this figure shows a basic block diagram of digital multimeter that consists of a different block. First one is the constant current source, then buffer amplifier, calibrated attenuator, current to voltage converter, calibrated attenuator, rectifier circuit, then input probes, rotary switch. Now as you know we are using here a rotary switch. The purpose of that rotary switch is for when you have to measure different quantities, either these are used for measuring voltage, for measuring current, either for measuring a resistance according to that. As there are two test probes that are connected to a 2 points between which the measurements of AC or DC can be takes place. The positive probe is connected to the function selector or rotary switch and negative is connected we can say to a ground. So basically first one is the we can say constant current source that are used for selecting a particular measurement purpose. So basically first block one we can say as a DC voltage attenuator, also we call this as a calibrated attenuator. This is basically a resistive potential divider with multiple resistors are connected in series between the input and ground pin. The function of this block is to attenuate the DC voltage applied at its input and connect the attenuated DC voltage to a ADC. A rotary switch is used to as a voltage range for amount of attenuation provided to the input signal. Next one is the rectifier and current to voltage converter. Current to voltage converter are used for converting current quantity to voltage quantity. Voltage to current converter used for converting voltage quantity to a current quantity. Then next block is the rectifier. Basically rectifier converts AC voltage to a DC voltage. It attenuates to a proper level with the help of potential divider and voltage range collector switch. Then next one is the current to voltage converter. The DC current to be measured is applied to this block via function selector switch. DC unknown current at the input is passes towards a known resistance to produce a DC voltage across it. This is proportional to DC unknown current, and this voltage is applied to again a DC block. Next one is the resistor to voltage converter. Input probe is connected to the block via the function selector switch when an unknown resistance is to be measured. A known DC current from a constant current source is passed through unknown resistors to produce a DC voltage proportional to a resistance value, and this again value applied to analog to digital converter. Now that analog to digital converter, that will convert all the analog value to a proportional DC voltage, digital value, and that digital value will display on a digital display. Basically, in a digital multimeter, you can consider advantages as it having a high input impedance, accuracy, automatic range selection, then multiple parameters we can measure by using digital multimeter. So for exam point of view, this block diagram is important and I have to explain this block diagram. Suppose question is like this: draw the block diagram of digital multimeter and explain in detail. This is, we can say, as a one layout of digital multimeter. The top portion is nothing but that contains a digital readout data which display the measurement values. Then below are the different function select switch. That function select switch are used for measuring either a voltage quantity, either current quantity, either we can say ohm meter for converting, we can say, as a range, either our voltage suppose are in a millivolt, either in a volt, current in ampere, either in a milliampere as compared to, and then that two pins that are used for, one is a positive probe, one is the negative probe, that is connected to a particular function. This is again function select switch. There are total 8 different functions to choose. First one is, we can say, as a off function. Then next one, this meter should be written to always this position. V marks as a AC voltage, this V dash as a DC voltage. Then another, these are the different AC voltage ranges, these are the DC voltage ranges, these are the current ranges, these are the different ohm meter ranges, and this is nothing but used for a continuity checking. So in that again, okay. So in that, that dial basically used for to measure the value greater than the voltage being measured. So for our lab, we will be working with a voltage of 20 volt ranges. Basically, when we are using here a current to voltage converter, here we can consider as a one op amp circuit, that is a current to voltage converter that used in a DMM. Basically, DMM. Basically here we are using a one op amp circuit with input resistance as a infinity and its input current is a 0. But when we apply the concept of a virtual here short, we are saying that our voltage become a 0 and our output voltage of this circuit is directly proportional to the input current, hence the name as a current to voltage converter. The output voltage is applied to the ADC for, we can say, as a further processing. So basically in our lab we are using a digital multimeter instead of analog multimeter because it gives higher accuracy. There are different application of digital multimeter. So first application is nothing but AC to DC voltage measurement. Then second one is AC to DC current measurement. Then third one is the resistance measurement. Then fourth one is also we can, as we are using application as these different ranges, also we use the digital multimeter for diode and transistor testing, whether our particular diode is in a working condition or not. Also we can use that as a transistor, whether our transistor is in working condition or not. Also we can use that multimeter for checking a probe, means CRO probe, cathode ray oscilloscope. By using that probe we can say that we are getting that particular probe okay or not, means that particular probe calibrated or not. So this is the first topic and this is very important. Question may be asked like this: draw the block diagram or we can say functional block diagram of digital multimeter and explain in detail working. In that you have to write a first working principle of this digital multimeter, then you have to draw this block diagram. This block diagram you have to draw and you have to explain this block diagram, and after that you have to write advantages and application of this particular multimeter. So this is the first topic in our unit number 1.